Welcome to this TSAS Tech Talk regarding grounding and bonding. First, let's be straight. As per the Canadian Electrical Code, grounding and bonding are really two different things. Grounding is the intentional connection to the earth using a grounding electrode to establish a zero reference and stabilize an electrical system. Bonding is the intentional interconnection of conductive surfaces to create a low impedance fault return path to safely conduct any current imposed upon it. Here are some key points about grounding. Grounding should be accomplished at one point and one point only on an electrical system. The intent of grounding is not to conduct fault current. Grounding electrodes are any of a minimum of 2 ground rods, 1 ground plate, a field assembled grounding electrode, or in situ grounding. Finally, grounding can typically be accomplished with a number 6 gauge copper wire. Here are some key points about bonding. Bonding must ensure all metallic surfaces, which may become energized, are interconnected with a low enough impedance path to be able to conduct any possible fault current they may be exposed to. Because of the requirement to carry the fault current available in the system, the bond must be sized to Table 16 of the Canadian Electrical Code. Let's have a practical discussion relative to new electrical system installations. Note, it really doesn't matter if it's a 12240 volt 100 amp house service or a 347 600 volt 1200 amp commercial building service, or even a 600 to 12208 volt transformer in an industrial building. It's all the same conversation about a new system. For any new system, the grounding requirements are the same. A stable interconnection to earth is required as per 10200 rules in the CEC. In these same new systems, the bond is where there are differences, as the bond must allow a fault return path for available fault current until overcurrent devices operate to disconnect the current flow. In all systems, it is expected that the ground connection to the neutral occurs as close to the supply of current as possible. Many times, this is in the meter socket. The connection from grounding system to the neutral is accomplished with the system bonding jumper, which must be sized as per Table 16 of the CEC based on the available fault current of the system in question. At this ground point, the attempt is to set zero reference point and stabilize the system. Service raceways must be bonded based on the maximum ampacity of the service conductors, as there are no overcurrent devices to limit fault current. Once past main overcurrent devices, bonding size is determined from the overcurrent device size for feeders and branch circuits, and still from Table 16. Note the bond facilitates the operation of the overcurrent devices. Be sure to review the rules of Section 10, and don't be afraid to talk to the local electrical inspector. Do it right the first time. That's all for now. Hope you found this TSAS Tech Talk informative. Have a great and safe day.